So today we shall solve organic chemistry problems. The problem is write the structure of all isomers of dichloroethene. Which one of these will have zero dipole moment? So the solution for this is, let's try to write down the first of all dichloroethene. I'll write the normal formula, that is ethene molecule. So there must be a double bond, C double bond CH, and they said that to dichloroethene. So dichloroethene means here you put the 1 chlorine and here also you can put the 1 chlorine. So they said here write the structures of all isomers of dichloroethene. So we need to write down the all possible isomers. So in that first possible isomer is, you just put both of these chlorine atoms on the same carbon. Let us put the two carbons like this: chlorine, chlorine, hydrogen, and hydrogen. Name of this molecule is 1,1 dichloroethene. So next, second one is, you have to keep both of these chlorine atoms on the two carbon atoms. So while keeping these two chlorine atoms, you may keep them in the same side or on the opposite side. So if you keep them on the same side, we get one geometrical isomer, that is cis 1,2 dichloroethene. Similarly, third one is, you just take the trans, keep the chlorine atoms on the opposite side. So we get the trans 1,2 dichloroethene. So these are all possible isomers, and among these, which one of these will have the zero dipole moment? So zero dipole moment is possible with the trans compound, because the moment of this particular polar bond is towards this side, and here the moment of these electrons or the charge will be towards this side. They get mutually cancelled out, so the dipole moment value is equals to 0 for the trans isomer, but possible isomers are 3. So the next question is, propene reacts with HBr to give isopropyl bromide but does not give N-propyl bromide. So for this we need to write down the reason and solution. You just see, first of all write down the propene, CH3 CH double bond CH2. This is the molecule called as a propene. So propene, when subjected with the HBr, so initially it forms a stable carbocation, secondary carbocation, which on further reaction with the bromide ion and produce the isopropyl bromide or else 2-bromopropane. And it will not give N-propyl bromide because secondary carbocation is stable. So in the absence of peroxide, the mechanism follows via this formation of the stable carbocation. If you use peroxide, then we will get the N-propyl bromide, not the isopropyl bromide. So let us solve the next question. So the question itself is very clearly says that acetylene is acidic, but it does not react with NaOH as well as KOH. So the solution for this is, acetylene is very weak acid. The Ka value of acetylene is 10 power minus 25. It is so very less that it is unable to produce the H plus ion to react with the bases like alkali bases like NaOH or KOH. But at the same time, if you use so strong base than even NaOH and KOH like sodamide, which is stronger base than NaOH and KOH, so this type of the stronger bases can easily abstract the proton from the acetylene and they react. So acetylene react only with the strong bases, not like NaOH and KOH, but these are also considered as the bases, but you can consider the OH minus ion and NH2 minus ion. NH2 minus ion is a stronger one. So let's try to go for the next question, question number 4. So the question itself is, ethene on treating with the Br2 in presence of NaCl forms a mixture of Cl, CH2, CH2Br and dibromoethane. Give reason. First of all, we need to see the mechanism of this ethene with the Br2. So ethene reacts with the Br2, forms this pi bond, electrons attacks over here and removes the Br minus ion. So here what happens initially, though there is a transition state, but I am not writing this transition state, straight away I am writing the carbocation. So positive charge will be formed. So this positive charge, you can see here, now this positive charge will be attacked by two negative ions, two nucleophiles. That is NaCl, here we said that we have taken the NaCl, it dissociates into Na plus and Cl minus ion, and one more thing is Br minus ion. So if Cl minus ion attacks, then we get the Cl, CH2, CH2, Br, and if Br minus attacks over that positive charge, then we will get the Br, CH2, CH2, Br. So there are two possibilities for this carbocation to be attacked by both of these anions, nucleophiles. So now let us solve the another question, question number 5. So the question is, how can you prepare benzene from lime, calcium oxide? It is simple thing that when calcium oxide or lime is reacted with the coke in the presence of the electric furnace, carbon combines with the calcium and removes the oxygen also, so that forms the CaC2, calcium carbide plus carbon monoxide will be removed. The formed calcium carbide CaC2 on reaction with the water, it produces C2H2 acetylene plus calcium hydroxide. So that is the reason why calcium carbide is called as the acetylide. And the formed acetylene C2H2 on trimerization, means when you allow this acetylene gas to pass through the red hot iron tube at around approximately 600 degrees centigrade, we get benzene on trimerization. So this is the procedure to follow and to get the benzene. So the first question is, 2-methyl propane can be converted into isobutyl bromide by hydrogen bromide. Write the condition. Solution. So the given reaction is 2-methyl propane on reaction with HBr and giving the isobutyl bromide. So in this particular reaction, hydrogen is added to the multiple bonded carbon, double bonded carbon with a less number of hydrogens, and bromine to the more number of hydrogens, means the required conditions to carry out this reaction is peroxide is required. So condition is, in presence of peroxide this reaction will happen. Now let us see the question number B, that is, ethane and its derivatives will give white PPT with ammonical silver nitrate. Mention the condition under which this statement is true. So it is simple thing that not only ethane, any terminal alkyne, an alkyne having this triple bond CH reacts with the AgNO3, ammonical silver nitrate, in the presence of the ammonium hydroxide. So they produce the silverides, silver alkynides. But if you take the an internal alkyne like this, or simply R dash, then if you treat with the ammonical silver nitrate, there will be no such type of the reaction. So the required condition for this reaction is the presence of the triple bond CH. So only under this particular condition this statement is true, but under this particular, means internal alkynes, this statement is wrong. Now let us solve the another question. Question number 6 is over, I think. Yes. Now question number 7. The given question is 36.4 grams of 1,1, 2,2 tetrachloropropane was heated with zinc dust and the product was bubbled through ammonical silver nitrate. So first of all, we will write down what is the structure of the 1,1, 2,2 tetrachloropropane. So there shall be 3 carbon atoms, in which first carbon atom 2 chlorine atoms are there, and second carbon atom also there are 2 chlorine atoms, and here no chlorine atom, so that's CH3, and here also we need to fulfill the balancing. This is called the 1,1, 2,2 tetrachloropropane. So this was heated with, they said, zinc dust. What is the purpose of the zinc? It is a dehalogenating agent, replaces only halogens. So it replaces this 2 chlorine, here also 2 chlorine, so that after the removal of the 2 molecules, 2 bonds will be developed between these 2 carbon atoms. So we get the CH3, C triple bond CH plus 2ZnCl2. So what they are saying is, whatever the product is obtained in the first reaction was bubbled through ammonical silver nitrate. So we will write down the second reaction, that is CH3 C triple bond CH was bubbled through ammonical silver nitrate in the presence of the ammonium hydroxide. And they are asking, there is a one precipitate is formed, what is the mass of the PPT obtained? So this is the terminal alkane reacts with the silver nitrate, ammonical silver nitrate, and gives the white PPT, silver propionide. Okay, so silver propionide is the molecule, and afterwards remaining reaction means remaining byproducts. If you want ammonium nitrate and H2, these are the byproducts which are not necessary for us. These are the equations involved in this reaction, but they are asking what is the mass of this product obtained. If you observe one thing, that let us write down the moles concept, moles wise. 1 mole of this particular compound is giving the 1 mole of the acetylene. What is the 1 mole of this particular molecular mass? The mass of this 1 mole of this molecule is 182 grams per mole. So 182 grams of this compound is giving, the molecular mass of this compound is 40. So 182 grams of this 1,1, 2,2 tetrachloropropane is giving 40 grams of acetylene. Then how many grams of 1,1, 2,2 tetrachloropropane they have taken? Only 36.2 grams. So 36.4 grams, 4 grams can give how much mass of the propane. So that mass of the propane obtained in this case is just do the cross multiplication. 36.4 into 40 divided by 182. So that you shall get the 8 grams. So that 8 grams of propane is involved in the next reaction. But here also 1 mole reaction is there. Let us see again. The molecular mass of this propane is just now we calculate, that is 40 grams. So 40 grams of this propane is able to produce 147 grams of propionide, acetylene propionide, silver propionide. Okay, because silver molecular mass is 108 plus 39, we will get the 147 grams. Then how much actually propane is obtained in the first step? 8 grams. Then 8 grams of propane is able to produce how much of this precipitate? This is the white PPT. Then we need to calculate that mass of the PPT obtained is just do the cross multiplication. 8 into 147 divided by 40, that is equals to 29.4 grams of the PPT is obtained in this particular step. Now let us see the another question. The given question is, compound capital A contains only carbon and hydrogen. So first of all, we will write one thing, that there is one compound capital A. It contains only carbon and hydrogen. We don't know what actual molecular formula is. So this particular compound capital A decolorizes bromine in CCl4. So Br2CCl4, it reacts with the bromine CCl4 and it completely decolorizes the compound. I am not writing the product as I don't know the reactant. And the same molecule reacts very slowly with the concentrated sulfuric acid. So concentrated sulfuric acid reacts slowly. Okay. And the same compound A, capital A, reacts with HBr to form capital B. So this particular compound on reaction with HBr giving the compound B. This compound B reacts with NaOH to form compound C. So this one on reaction with the NaOH gives the compound C. And this particular compound C on oxidation gives a compound this compound C on oxidation gives hexanone 3. Hexanone 3. So what is the structural formula of A, B, C and explain the reactions involved they are asking. It is easy to understand that compound A reacts with the bromine CCl4 decolorization means this compound must be an unsaturated compound. Unsaturated compound and reacts slowly. So reacts slowly, this one also suggests that it is an unsaturated compound. Both are unsaturated compound. Now, here in this particular process, there is no opening of any ring. Ring is not involved and there is no loss of the carbon dioxide, nothing. Means whatever the number of carbon atoms are present in the final compound will have the same number of carbon atoms in all of these A, B, C compounds. So I'll write down the reverse reactions here. You just see, I'll write down the hexanone 3 molecular formula first of all. CH3, CH2, C double bond O, CH2, 1, 2, 3, 4, 5 and 6. This is hexanone 3. So this hexanone 3 was obtained from which compound? Some compound on oxidation, that is option C, compound C. So oxidation means compound C and oxidation gives the ketone. So only secondary alcohols gives the ketones on oxidation. So the C compound also will have the same type of the molecular arrangement, atomic arrangement, but this carbon will have the OH group. So we can write the molecule like this: CH3, CH2, CH, OH, CH2, CH2 and CH3. This is secondary alcohol which is a compound C. Now this compound C is obtained from the compound B by treating the B with the NaOH. So here OH is introduced at this particular place. Okay, means at this particular place some other nucleophile must have present. That nucleophile must be the bromide because A is treated with the HBr, so that a bromine has to come into the B molecule. That bromide ion was replaced by the OH minus and so that we got the compound C. So compound B also will have the same molecular arrangement, atomic arrangement except this OH. So we must have this CH3, CH2, CH, Br, CH2, CH2 and CH3. So this one on reaction with the NaOH and gives this particular molecule. So this is the compound B. Now this compound B is obtained from the A, which we said an unsaturated molecule, by subjecting with HBr. Means compound A on reacting with the HBr. So from this it is very clearly understood that here only one OH is there, here only one bromine we expected, because here only one keto group is existed. That means that here only one HBr might have involved in the reaction. Only one HBr is involved means the compound A must be an alkene. If it is an alkyne, two HBr molecules might have involved. So this particular one molecule may be an alkene. So Alkene means hydrogen one side and bromine one side will be added to the double bonded carbon atoms. So you can take a double bond between these two carbon atoms or these two carbon atoms, you will get the same molecule. So that I am going to write down the compound A, which on reaction with HBr gives the compound B, that is CH3, CH double bond, CH, CH2, CH2, CH3. So usually people may get the doubt, sir, here though it is an unsymmetrical alkene, but both of these carbon atoms are having the same number of hydrogens. So when HBr is added, what is the reason for this hydrogen to add only to this carbon atom, not to this carbon atom? See, let us see the means this is a compound A. First of all, I'll write here. So now let us see what is the actual mechanism involved. I'll take this compound A, CH3, CH double bond CH, CH2, CH2 and CH3. So whenever you add Ha plus ion to this particular alkene, there are chances for the formation of two carbocations. H plus ion, if it is added to this particular carbon, I am writing the molecule here, ion, that is CH2, CH plus CH2, CH2, CH3. If H plus ion is added here, then positive charge will be created over this carbon atom. CH3, CH plus, CH2, CH2, CH2 and CH3. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So two carbocations are there. Interestingly, both of these carbocations are secondary only, secondary carbocations. Then we need to analyze the stability of these carbocations by considering the two things, that is plus I effect. Second one is number of hyperconjugative structures. Okay. So this particular carbocation is having two larger groups are there, which is giving the electrons to this positive charge. To neutralize this positive charge makes this carbocation more stable. Okay. Or else if you take the hyperconjugative structures, here two hydrogens, here also two hydrogens, totally 4 alpha hydrogens including original structure. So there are 5 hyperconjugative structures are possible, because number of hyperconjugative structures equals to number of alpha hydrogens plus 1. So here 4 plus 1, so 5 hyperconjugative structures are possible. And in this case, here 3, here also, here 2 are there. So 3 plus 2, 5, and here positive charge is there. So this positive charge means totally 6 hyperconjugative structures we are getting. So 6 hyperconjugative structures and more number of structures are there, and moreover here it is releasing the electrons. The incoming electrons is more in this case. Why? Because both these sides larger groups are there. In this case, though this is the larger group, but other side a smaller group is there. So that electron density coming over to this particular positive charged carbocation is bit less compared to this one. They are nearly equal, but this particular carbocation which is more stable, hence Br minus ion preferably attacks over this particular carbocation and giving the CH3, CH2, CH, Br, CH2, CH2 and CH3, or else you would get the secondary bromo. And one more thing is, here also you will get the 2-bromo hexane. But the question in our question, one more important thing is, here O, oxygen, keto group is at 3rd position, so that OH must be at 3rd position, so that bromine must be at 3rd position, so that here bromine we have to get. So this particular molecule I am writing. Now let us solve the next question, question number 9. So the 9th question is an organic compound capital A having carbon and hydrogen. So there is an organic compound capital A which again having only carbon and hydrogen, and it is added only with 1 mole of hydrogen in the presence of the platinum. So only 1 mole of hydrogen it is adding means this compound must be an alkene, because alkynes react with the 2 moles of hydrogen, because number of moles of hydrogen equals number of pi bonds between the carbon atoms, or number of pi bonds involved in the particular molecule. So that normal hexane will be formed. N-hexane means this particular A molecule must be hexene. N-hexene means there is a double bond, but we don't know where the position of the double bond. So for that purpose we need to depend on the another reaction. So this particular A compound on vigorous oxidation with KMnO4. So this one with the on reaction with the vigorous oxidation with the KMnO4, it gives a single carboxylic acid containing 3 carbon atoms. So it is giving only one type of carboxylic acid, that too contains 3 carbon atoms. So the structure must be this one only with 3 carbon atoms. Apart from this, you cannot develop any structure with 3 carbon atoms, because COH is a terminal functional group. So here we need to see that carboxylic acid is formed, means this KMnO4 molecule has broken the carbon-carbon double bond, means wherever the carbon-carbon double bond is there, that double bond was broken by the KMnO4, and both of these carbon atoms are converted to their respective carboxylic acids. Carboxylic acids means you have to take the 2 of these molecules. So 2 of these molecules means here CH3, CH2, C double bond OOH plus, because it is giving only one type of the carboxylic acid, means 2 molecules can easily exist. C double bond O, CH2 and CH3. Now our duty is to remove these extra things added after the reaction with the KMnO4 and add these 2 carbon atoms by a double bond, so that we will get the original alkene molecule CH2, CH double bond, CH, CH2, CH2. So the name of the compound A is now hex 1, 2, 3, 3 in. This is the hex 3 in. Yeah, we'll continue the remaining questions in the next video. Dear students, if you like my explanation, do not forget to like this video, share this video to your friends, comment whatever you think about this video, and finally do not forget to subscribe this channel. Thank you all.